Now I'm going to solve 493 from Blue Book, and this is complex number question again. And U is given complex number. Find all complex numbers Z for which values the number A. Here the value is A firstly. This is nothing, only a written mistake. Okay, number A is equal to U minus U conjugate Z all over 1 minus Z is a real number. We are going to show this one. Firstly, I need to explain this one to you. When a number is real number in complex number set, if you are using complex number division here, this is complex number division, and the result is real number. In which condition this is it's possible? I'm going to explain that one. Complex now, if it is real number, conjugate of it, it's going to be itself. So A and A conjugate, it's going to be itself. Which means if U is equal to A plus BI and Z is equal to X plus YI, and U is equal to, instead of A plus BI, let me use another form, U is equal to C plus DI, then here the U conjugate, it's going to be equal to C minus DI, or Z conjugate, it's going to be equal to X minus YI. But if the A is real number, like A is a complex number, A plus 0I it's going to be. And here this number, it's conjugate of it, A minus 0I. Also this is not written, so both of them, they are equal to A. So we are going to try to prove this one. And here we are understanding that if a number is real number, if A is real number, then A must be A conjugate. So U minus U conjugate Z all over 1 minus Z, it must be equal to U minus U conjugate Z all over 1 minus Z conjugate. They are going to be equal to each other. Then here U minus U conjugate times Z all over 1 minus Z is equal to U conjugate minus U conjugate and conjugate, but U conjugate, it's going to be itself. First, we need to understand that one. So it's going to be U and Z conjugate all over 1 minus Z conjugate. Conjugate of 1 is equal to 1. Again, it's real number and it's going to be itself. And conjugate of Z conjugate I have written. Now the operation that I'm going to do, I'm going to cross and multiply them to get one equation here. 1 minus Z conjugate times 1 minus Z conjugate times 1 minus, U times U minus U conjugate Z is equal to 1 minus Z times U conjugate minus U Z conjugate. It's going to be. Okay, I'm going to get this expression to this side a bit, and I'm going to change the color of it to do better operation, to understandable operation. Now, by using the distribution rule, I'm going to multiply these are one by one. 1 times U is equal to U. 1 times U minus U conjugate Z minus U conjugate Z, it's going to be minus Z conjugate times U is equal to minus U times Z conjugate. I'm writing this at the end always. And the last one is U plus, it's going to be firstly this one, plus U conjugate Z conjugate times Z, it's going to be. Then it's going to be equal to, on the other side, if I do the distribution operation one by one here, then this one and this one like this, it's going to be 1 times U is equal to U conjugate, 1 times U conjugate is equal to U conjugate, 1 times U minus Z conjugate is equal to minus U minus Z conjugate, Z conjugate minus Z times U conjugate is equal to minus Z U conjugate, and Z times here Z times U minus Z times minus U Z conjugate is equal to plus U z conjugate it's going to be. Then I'm going to get here this side. On the equation of both sides we have addition and subtraction, and these values are same, so I'm going to simplify them. Like I'm going to cancel them here. This term and u conjugate, these are same values, they have same values, that's why I'm going to simplify them. First this one and this one also. So we left these terms back. U conjugate z, u conjugate minus u conjugate z conjugate z. I'm going to get this side u conjugate, and this one minus u z conjugate is equal to 0. It's going to be. Here I need to remind you about z times z conjugate, what it is. Z times z conjugate, if you remember, z if it's equal to a plus bi, and z conjugate if it is equal to a minus bi, then z times z conjugate, which is equal to modulus square, it was modulus square, and that's equal to a square plus b square. It's going to be, I used again a and b, sorry for that one, it should be x and y. It's better to write with x and y. X plus yi, then x minus yi, then z times z conjugate is equal to modulus square, which is equal to x square plus y square. So I'm going to use this one in the equation, so it's going to be like this. Z times z conjugate, I have u minus u conjugate minus u conjugate times z module square minus u times z module square again is equal to 0. So I have here z module square in both expression. I'm going to simplify this one. I'm going to get common term parentheses, and it's going to be like I have here, I think mistake, this is going to be plus u conjugate z, yes, this is going to be plus. And then one of them is minus, one of them is plus. This one came from the other side, that's why this is going to be minus. That's okay. But this one, okay, u minus u conjugate, and now if I get z module square parenthesis, I will get u conjugate minus u. So I will get this one, z module square, if I get u conjugate minus u, if I get this parenthesis. But this term here, u and u conjugate, and u conjugate minus u, u minus u conjugate, and u conjugate minus u, they are additive inverse of each other. That's why it's better to get minus parentheses. So I'm going to do like this, minus, then I'm going to change the signs of this one. It's going to be like this, u minus u conjugate. What I mean multiplicative inverse, x minus y is equal to minus y minus x. So I made this one here. Okay, then I change the sign, and I change the signs of the expressions, and I got the minus sign in front of it. Then if I continue, u minus u conjugate minus z module square u minus u conjugate is equal to 0. Then this expression and this expression is same, and I know that there is invisible coefficient here. 1 minus z module square in parentheses times u minus u conjugate is going to be equal to 0. Then multiplication of this result, if it is equal to 0, 1 minus z module square is equal to 0, or u minus u conjugate is equal to 0. U is equal to u conjugate. So here we can make this Yes, here u minus u is equal to u conjugate. This means the number is real number, but at the beginning it mentioned that u is complex number. U is given complex number. Every complex number also real number, but I think in this question, if a is given, especially that's real number, also they need to mention u may be also real number, but it is not given like that. So I'm going to do like this: u is equal to u conjugate, or 1 minus z module square is equal to 1. It's going to be, so a is real number. A is real number if z module square is equal to 1. So the solution of this for all z were such that z module square is equal to 1 is the solution of the question. It's going to be.